Okay, so we ran out of time in class for change of base. This is going to let you put any logarithmic expression into your calculator, regardless of the base. So if I have, let's see, any base, what you're going to do is select any other base that you want. You're typically going to select base 10 or base e, so you can use your calculator. So let's look at the examples down here. The base that you're given, you can use with log 10 and put that log base 10 of that original base in the denominator, or you could use natural log, which is base e, and I'd put in the denominator natural log of what your original base was. So the original base goes in the basement of the fraction. Then whatever was the original argument of your logarithm goes with a matching base, either base 10 in the numerator or base e in the numerator. Okay, so the original argument goes in the numerator. The original base goes in the denominator. We typically use this so we can convert to base 10 or base e and use our calculator. Technically, you can rewrite and convert to any base you want, as long as the base in the numerator and the denominator are the same. And then the original base is the argument in the denominator, and the original argument becomes the argument in the numerator. That's the change of base formula. Go ahead and get your calculators out. Pause the video, get calculators out, restart the video. And for these examples, we could do base E or base 10. You have a button on your calculator for both. And unlike the property of logarithms, where you just have one logarithm, this is a different formula. So we have a log divided by a log. I'm using base 10. The original base goes in the basement, and the original argument goes in the numerator. With parentheses, enter that into your calculator. And you're going to get, I thought I had the answer written on my paper. I do not, so give me a moment. I'm going to catch up with you. Log parentheses of 1 divided by 5, close the parentheses, divide by log, parentheses, whoops, they were already there, 1 divided by 7, close the parentheses. And I got 0.827. You'd get the same exact value if you had used the natural log button. Whatever button you pick, you have to be consistent. Okay. So the next one is base 4. Let's go ahead and use natural log for this one. Natural log divided by natural log. The original base goes in the basement. The original argument goes in the numerator. Natural log of 6, close the parentheses, divided by natural log of 4, close the parentheses, equals 1.292. All right, and that log base 10 button is the one towards the top left that says LOG, and the one right below it, LN, is the natural log. And remember, when we're finding a logarithmic value, we're finding an exponent. We're finding an exponent that we needed for base 4 to become 6. So we were trying to calculate base 4 needs what exponent to become 6. We just found it, 1.292. If we wanted to check our answer, we would take our calculator, 4 to the 1.292. Now that's rounded, so this is going to be approximate, but it should be approximately 6. 4 to the 1.292. And I get 5.99, 599, very, very big. So that's basically 6. We just found the exponent needed to make 4 become 6. Then there was a different questions at the end that allowed us to use the properties of logarithms a little bit more, and you will see questions like this in ALEKS. We did some like this already in class, not a lot. We're going to condense. We're going to start by writing each as a single logarithm, or not necessarily. Actually, now that I look, we'll do some different things. But we'll be able to simplify some more, so I get to show you why the properties are a little helpful. Here we have 2 logarithms that are subtracted. I needed a highlighter. Let me grab a highlighter. 2 logarithms that are subtracted. Before that, I notice I have a coefficient here. So I want to make that coefficient become an exponent instead, which gives us log base 2 of 36 minus log base 2 of 3 squared, which is 9. And because of that subtraction between the logarithms, we can write that as 1 logarithm base 2 of 36 divided by 9. 36 divided by 9 is 4. So we have log base 2 of 4 that can be simplified. What value, what exponent, this is what you're thinking. Let me write down what we're thinking. 2 with what exponent is equal to 4? That's right, 2. So number 1, using properties of logarithms simplifies down all the way to 2. On the next one, and we'll see these properties a little bit more. They weren't in today's notes, but it's pretty easy. If you have a logarithm of e, this expression right here is not base. It is base e, but the e that you see is not the base. You have logarithm base e of e We didn't see this with natural logarithms, but we did see the property with basic properties of logarithms. And the one that we saw in class said log base b of b to the x is just equal to the exponent. And that's because log base b of b, because the 2 different types of bases match, they are inverses. Okay, so that's the property that we're using right now, except that it's natural log. So natural log of e, and we just end up with -8 plus 3, which is 5. Let's do that again. Another way we can think of it, glad we have another one because there's another way I could think of it. I could have, like I did with other examples, I could have moved my exponents first. So 5 natural log of e minus 2 natural log of e. Whoops. Keeping in mind that the natural log is base e. And we had another property that I get to review that said, one of the basic properties of logarithms said log, whoops, I forgot my O, let me squeeze it in, oh my, log base b of b equals 1. Clean that up, there we go. Log base b of itself. So as long as the bases match, you get 1. So that's what we get right here, 1. And right here, natural log of e is equal to 1. You can put it in your calculator. Just type it in, natural log. There's an e button on your calculator, and you're going to get 1. Now we have 5 times 1 minus 2 times 1, or 5 minus 2, which is 3. We're going to talk about this with inverse properties where we can just go like this. But I wanted to also explain it the way we did things in class. Last one. I notice a coefficient, so I'm going to move my coefficient, make it an exponent. Instead of a coefficient, making it an exponent, 3 squared is 9. Now we have log base 6 of 4 plus log base 6 of 3 squared, which is 9. Because I'm adding 2 logarithms, there is a property that allows me to write as 1 log base 6 if I multiply the original arguments. 4 times 9 is 36. Now everything's running together. That's a separate thought. And what is log base 6 of 36? Those of you in class will be able to come up with that because you're just trying to think, what exponent do we need on 6? 6 to what power equals 36? And you're right, it's 2. So that's where the properties start to be a little bit more useful, because as you use the properties, you might be given the opportunity to do extra simplifying that you couldn't do before. That's the change of base formula. Go ahead and start homework 11.